Welcome students to another online learning video material. This is course differential equations with Math 810 R4031. The unit is 2 of block 5 offered by the Department of Mathematics, Kalasalingam Academy of Research and Education. So let me start today's topic. I have already introduced a homogeneous linear second order PDE of second order PDE. Okay, and now in this section I will be introducing non-homogeneous. Let me write it. Non-homogeneous second order linear PDE with constant coefficients. Okay, so the general form of this equation will be like a into uxx plus b into uxy plus c into uyy plus d into ux e into uy plus f into u equal to g, and this g not equal to 0, then only I will be saying this is a non-homogeneous. And a, b up to g all are constants. Okay, so this kind of second order PDE is called linear with constant coefficients and also non-homogeneous. So in the case of homogeneous differential equation, I have already told you how to find the solution, and in this case that is non-homogeneous, so there are two parts in solution. One is complementary function, which will be obtained for the homogeneous part of the given problem, and another one is particular integral. Okay, now if I give you a problem, suppose this equation only you consider, this general equation 1. Okay, the solution of the homogeneous part, that is when g equal to 0 of 1, is known as complementary function. In short, I will be writing it as c dot f dot, complementary function. Now the solution of the equation 1 will be complementary function plus particular integral. In short, I will write it as pi, and I will be also discussing how to find pi for a non-homogeneous second order PDE. Okay, so let me go to the next page, and let me start with some special type. Suppose your in the previous slide, suppose the left hand side of this, let me take a new color for that and let me underline it, this left hand side of equation number 1. Okay, let us write it as f of d comma d dash. you know what is d and d dash. D is del x and d dash is del y. So this is equal to this left hand side, and in short we consider, change the color, consider the PDE as if t d dash equal to g. Okay, you know already how to find out the complementary functions, already discussed in the previous lecture video. Now I will be discussing how to get the particular integrals, that is the pi, how to find pi's. So that depends on the expression of g. So I will I will do it rule by rule. So today I will consider rule 1. Okay, so I will tell what is this. Suppose your g is a algebraic function of x and y. For example, your f of xy can be x plus y, x square minus plus 3y, or whatever, x to x minus y square, this. So whenever this kind of expression appears on the right hand side, then the common rule is you have to write your pi as 1 by whatever the equation is given to you, that is f of d comma d dash, and this way. Okay, now I will give you an example, then what to do after that. Okay, a particular example that will be easier to understand for you. Okay, so let us consider a problem as solve d square minus dd dash minus 2 dash square into z equal to 2x plus 3y. Okay, so this is the problem. So the complementary function is very easy. The auxiliary equation for the homogeneous part of 1, this is 1, equation number 1, is very easy. Just simply write m in place of d and 1 in place of d dash. So that will be m square minus m minus 2 equal to 0. So if you solve this, what you will get? You will get let us factorize, that will be m minus 2 to m plus 1 equal to 0. So your m is nothing but minus 1 and 2. Hence complementary function c dot f dot is nothing but phi 1 y minus x plus phi 2 y plus 2x. These phi 1 and phi 2 are arbitrary functions. So this part already known to us. Now let us consider the pi. Pi 1 by d square minus d into d dash minus 2 into d dash square of the right hand side. What is there? 2x plus 3. Okay, so I have already factorized it. If this can be factorized, as you know, as d minus 2d dash into d plus d dash of 2x plus 3y. Okay, now you take d common from each factors, so you will be having 1 by d square. Now this 1 minus 2 into d dash by d into 1 plus d dash by d into 2x plus 3y. Okay, so in the next step, 1 by d square, that will be 1 minus 2 into d dash by d whole to the power minus 1, 1 minus d dash by d whole to the power minus 1, that of 2x plus 3y. Now I have to expand this binomial expansion, so 1 plus 2 into d dash by d. Okay, that is nothing but d dash by d only, plus dot dot dot. I am not writing the rest of the terms since those will be 0 only, and here also I write it as 1 plus d dash by d plus I left at dot 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 only, because rest of the term will be 0, since this 2x plus 3y is a linear only, so I am not considering the higher derivatives. So anything more than first order derivative, all will be 0. That's why I have not written in this factor also. If this term is not linear, suppose x square is appears there or y square, then you have to write one more term here also, here also. Okay, both the places. Now I continue this case, 1 by d square, then 2 into d dash by d plus dot 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 dot. Now 1 into 2x plus 3y will give you 2x plus 3y. Now first apply this operator d dash by d to this. Okay, let me take another color for better understanding. Okay, I am applying this operator here. So first you have to differentiate this term, okay, I mean this term with respect to y. Then you will be having with you 3 only, right? Partial derivative of 2x plus 3y is 3. Next, 1 by d of 3. So as you know, I am writing it here. Okay, where should I write? Let me find some place. Okay, this place I am writing d dash by d 2x plus 3y. Okay, so 1 by d partial derivative of this expression is 3. 1 by d means what? Integration with respect to x, so that will give you 3x. So here in this place I am writing, yeah, 3x only. Okay, I think I have made a small mistake over here. Let me just correct it. This is plus, so therefore this plus will be minus. Okay, let me just erase it. I got it. Yeah. that will be minus only. Okay, so here I will in place of plus 3x I will get minus 3x. Okay, so let me correct that also. Okay. Yeah, that is minus 3x. Okay, now I guess it's okay for you. Okay, so let me move on to the next page. So now I can write it as 1 by d square, and do the square part, so that, yeah, d square into, oh, it was like 1 plus 2 into d dash by d, and here that will be minus x plus 3y. Okay, so let me continue with this. 1 by d square minus x plus 3y will appear here, and again I need to find d dash by d of minus x plus 3y. So let me take another color here. So as you know, first I have to differentiate this with respect to y, so that will give you 1 by d, so that will give you 3 over here. So now again I have to integrate 3 with respect to x. 1 by d means integration, so that will give you 3x. So here you write 3x. Okay, 3x, and 1 2 is already there, so 3x into 2. Okay, now let me get back my color. So ultimately you are getting 1 by d square into 6x minus, so that will be 5x plus 3y. Okay, now what you have to do, you have to integrate twice this expression with respect to x. So let me do one by one. Let's first integrate it once, so I will be left with 1 by d, and while I will consider this integration, I will take y as a constant function. So that will be, as you can see, 5 by 2 into x square plus 3xy. Then again you integrate it, that will be 5 by 6 then into x cube plus integration with respect to x, y is constant, so that will be 3 by 2 x square into y. In particular integral we don't consider arbitrary constants or arbitrary functions, that's why no plus c or pi anything. Okay, in particular integration only the expression will come, no constant term will come. So with that I finally found the particular integral. Okay, now let me write the final complete integral. So let me write it. Then the complete integral of the given PDE is given by z equal to complementary function plus particular integral. That is, we will have it this way. Let me just write it here. Z equal to, the complementary was already taken at phi 1 y plus 2x plus phi 2 of y minus x plus the particular integral, which is nothing but 3 by 2 into x square y plus 5 by 6 into x cube, where phi 1 and phi 2 are arbitrary functions. Okay, so this is the method when your non-homogeneous part is algebraic. Okay, so with that, let me stop today's lecture. With another rule, I will continue this section.